Welcome to Gate for today. Every day I'll solve one previous gate question with explanation. For this day, that is on 7/10/23, the gate question it is given in 2023 gate. In a semiconductor, if the Fermi level lies in the conduction band, then the semiconductor is known as options are degenerate n-type, degenerate p-type, non-degenerate n-type, non-degenerate p-type. This is the question given. Now, I'll see the answer with the explanation. I'll start the answer with Fermi level. Okay. For this Fermi level, to understand this Fermi level, let me draw the diagram, energy band diagram of a semiconductor. Yeah, this is conduction band. This is valence band. This is called the valence band energy level, and this is called the conduction band energy level. And this is called forbidden energy gap. This is the band diagram, energy band diagram of a semiconductor. Now, Fermi level means it is the minimum energy level. It is the minimum energy level occupied by the electron at 0 degree K. That is Fermi level. I'll explain what is Fermi level actually. Suppose see this band diagram. Let this Fermi level be like this. This is the Fermi level. And remember, the energy will start from this. This is 0 and the energy will increase like this. Okay. So now, if this is the Fermi level, now what is the meaning of Fermi level? It is the energy level occupied by the electron at 0 degree K. Means all these levels below the Fermi level, see, all these levels below the Fermi level are occupied by electrons. All the energy levels above this Fermi level are empty. Okay. So now this is the Fermi level occupied by the electrons at 0 degree K. Above the Fermi level, all the energy states are empty, and below the Fermi level, all the energy states are filled. That is Fermi level. Okay. Now, I'll see Fermi level in intrinsic semiconductor. Fermi level in intrinsic semiconductor. Intrinsic semiconductor means pure semiconductor. In the intrinsic semiconductor, the Fermi level is F is equal to EC plus EV by 2. When the effective mass of the holes and effective mass of the electrons are equal, then the Fermi level is EC plus EV by 2. What is the meaning of EC plus EV by 2? See here, in the band diagram, this is EC and this is EV. This EF is exactly at the middle of your forbidden band, like this. It is exactly at the middle of your forbidden band. So that is for intrinsic semiconductor. And Fermi level in extrinsic semiconductor. Fermi level in extrinsic semiconductor. That too, if you go for n-type extrinsic, the Fermi level is F is equal to EC minus KT ln NC by ND. Okay. So what is this? Take the bond diagram. This is valence band and this is conduction band. This is EV and this is EC. So in the n-type material, the Fermi level is below the conduction band energy level, means it is nearer to the conduction band energy level. The reason is to generate n-type extrinsic semiconductor, we have to dope with pentavalent atoms. Pentavalent atoms has 5 electrons in their outermost orbit. 4 of those 5 electrons forms bonding with the pure silicon and 1 is vacant. So with the help of external energy, you can break that bond and that electron becomes free. So you'll get more number of electrons. All those more number of electrons present in the conduction band means the conduction band is having more energy level. So that is the reason, as electrons are more, the energy more, Fermi level is shifted to the conduction band. Okay. So here what is NC? NC formula is 2 into 2 pi mn k bar t by h square whole power 3 by 2. And what is ND? ND is nothing but donor ion concentration. Okay. So this is about Fermi level in n-type semiconductor. Now in p-type, Fermi level is EV plus KT ln NV by NA. Okay. Here also, if you see the band diagram, this is valence band and this is conduction band. This is EV and this is EC. And here the Fermi level is nearer to the valence band, like this. Reason is, you know, the p-type is formed with trivalent impurity. Trivalent impurity consists of 3 electrons in their outermost orbit. Number of holes will be increased. All the time one hole will be formed and that gets filled by the electron. Another hole will be formed that gets filled by the electron. Okay, so holes will be increased. That is the reason in p-type semiconductor the conduction is due to holes. But what happens to the energy level? Because as the electrons are occupying the hole all the time, the energy of the electron will be decreased. That is the reason the Fermi level goes down and it is nearer to the valence band. Okay. And here also this NV equal to 2 into 2 pi mp k bar t by h square whole power 3 by 2. and Na is acceptor ion concentration. Okay. Now the actual thing comes. Okay. The doping is, if the doping is high. Okay. What is the meaning? Take N type. Doping high means the donor ion concentration is more. If Nd is more, then take the Fermi level equation Ec minus KTln Nc by Nd. Okay. If it is if it is more compared to this, what happens? Ln of Nc by Nd? If the denominator is more compared to the numerator, it will becomes Ec, this Ln becomes a negative value because the numerator is lesser than the denominator. So it becomes Ec plus KTln Nc by Nd. Okay. Then what is here the band diagram? This is Ev and this is Ec. Means this is conduction band and this is valence band. Now see here it is Ec plus KTln means the Fermi level is here. The Fermi level is here. Okay. So this type of semiconductor in which the Fermi level lies in the conduction band is called degenerate type semiconductor. As this is N type, it is degenerate N type semiconductor. Degenerate N type semiconductor. What is this actual meaning, degeneration? If the doping is high, what happens? Many free electrons will be generated. Means the conductivity will be increased. That is the reason it is called degenerate N type. Same way for P type, Na is more. And now consider your EF. Ev plus KTln Nv by Na. Okay. If again Na is more compared to this Ln becomes a negative value. So if it becomes a negative value, it becomes Ev minus KTln Nv by Na. Okay. Then what about the band again? Band diagram. This is valency band and this is conduction band. This is Ev, this is Ec. See here Ev minus. Ev minus means yes, the Fermi level is like this. So here also the Fermi level is inside your valency band. That is the reason it is called degenerate P type. What is the exact explanation? If the acceptor ionic concentration is more means, what is the actual meaning of it? If more number of trivalent atoms are added, more number of holes will be generated. If more number of holes are generated, more number of electrons will fill those holes. So the electron's energy is reduced. That is the reason the Fermi level drops down to the lower value. That is the reason it enters into the valency band. Hence it is called degenerate P type. Okay. Then there exists another one. What is that? Non-degenerate. Non-degenerate. What is meant by non-degenerate? Doping is very less. Doping is very less. If doping is very less, what happens? Suppose if in N type, if doping is very less, no free electrons will be generated. No energy will be increased. So the Fermi level may lies in the energy band like an intrinsic semiconductor. In the intrinsic semiconductor, we know the Fermi level is exactly at the middle of energy gap, forbidden energy gap. Okay, so if the doping is less, nothing will happen. Means the conductivity won't increase, number of free electrons won't increase. So the Fermi level lies inside that forbidden gap. Same way for P type also. If the acceptor ion concentration is very less, means the trivalent impurity is very less. So what happens? Number of holes will be reduced. So the electrons that are filling the holes are reduced. So totally what will happen? Nothing will happen. Conductivity won't increase. So again the Fermi level lies in the forbidden gap. Maybe like an intrinsic semiconductor. Okay. So that is called non-degenerate. So now in the given question, now if we see in the given question, what is the given question? In a semiconductor, if the Fermi level lies in the conduction band, then the semiconductor is known as, then what is the answer? The answer is degenerate n-type. Okay. So that's all for today. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.